Welcome and thank you for joining. In this lesson, we'll discuss the derivatives of reciprocal trigonometric functions. Recall that the primary trigonometric functions are y equals sine of x, y equals cosine x, and y equals tan x. The reciprocal of sine function is 1 divided by sine x, which we call cosecant x. The reciprocal of cosine x, or 1 over cosine, equals secant x, and the reciprocal of tan x, or 1 over tan x, is cotan x. We'll start off with proving each and every formula. So for y equals cosecant x, which equals 1 over sine, we are going to use this very formula here in the reciprocal form of the primary. And further to this, we'll rewrite cosecant x as sine of x to the power of -1. Now, we've learned how to differentiate the sine functions. And we know that the derivative of sine equals cosine. The derivative of cosine is negative sine. And the derivative of tan is negative secant squared x. So once you have the equation expressed of the function expressed in terms of the primary trig function, then we'll start differentiating, considering this as a chain rule of the sine function, which we know how to differentiate. So dy dx equals, we'll start off with the outside function, which is a power function. So that means we have -1 sine of x brought to the power of 1 less than -1. So -1 minus 1, -2. And then we differentiate the inside of the function, which is the derivative of sine, which equals cosine x. Continue simplifying. So we'll make the negative power into a positive by bringing sine of x to -2 down in the denominator. That turns into sine x power of +2. And now we will rearrange the trig terms in here. We have negative cosine x, and rewrite sine of x squared as sine x times sine x. So as you can see in here, we can combine the sine and the cosine from numerator and denominator here into cotan x. So this would be negative cotan x, and then multiplied by, as you can see in here, we have sine of x in the denominator, so I'll rewrite this as 1 over sine x, just so we can see a little bit better. So this term here is going right here. Now 1 over sine x is the reciprocal of sine, so cosecant. So we end up with negative cotan x and then cosecant x. So as a result, then we're going to say that the derivative of the cosecant function would equal cosecant function itself multiplied by the cotan function with a negative. And if we have a function inside the angle, a function u, dependent on x, then we have to multiply by the derivative of the inside, which is du dx. So if you want to remember or memorize the simplified version of the derivative of cosecant, then you would write cosecant x derivative equals. So I like to remember the fact that the derivative of cosecant will have one of the factors itself, so the cosecant x. And then it will have another ratio that starts with a co, and that's cotan x. And whenever we differentiate terms, trig terms that have a co in it, we always end up with a negative sign. So we call this coco minus. So we'll continue with the next function. So y equals secant x. We'll follow the same strategy. You can try this on your own because that's more fun. So we'll rewrite y equals secant x equals 1 over cosine, or even better, cosine of x to the power of -1. Let's start differentiating. dy dx equals, so the outside function here will be the power function of -1. So we go -1, decrease the power of -1 by another one, so to the power -2. And inside we have the cosine x. That doesn't change. So now we are differentiating the inside function, cosine x. The derivative of cosine is negative sine x. Simplify. Bring the negative power down to the denominator, and in the meantime we'll multiply these two negative coefficients. So -1 times -1 will make a positive. So in the numerator we'll have the sine of x, and denominator will have the cosine x to the power of 2, which we will rewrite as sine of x divided by cos x times cosine x. Similar to what we did in the previous proof, we'll combine sine and cosine. This time they will make a 10x times 1 over cosine x. Now 1 over cosine x would be the reciprocal of cos secant. So that would be 10x secant x. So therefore, we're going to say that the derivative of the secant function would equal the product of secant, so the function itself, times 10. And if you have a function inside the angle, or an inside function we say, then we have to multiply by the derivative of the inside. And the simpler version of this formula would be secant of x to the derivative would be equal to the secant of x multiplied by 10 of x. Very similar to the derivative of cosecant. So last we have the derivative of cotan x, which is 1 over 10. So here we have multiple options. We can write cotan as cosine over sine and use the quotient rule to differentiate. But I think that differentiating 1 over 10x would be easier. So we'll rewrite the function y equals cotan x in terms of 10 and in power form. Now we start differentiate. Remember, this will be the outside function, the power -1, and the inside function is the 10 of x. dy dx equals, we'll start off with the power function, -1, decrease the power by 1, so that makes a -2. Inside, we don't change anything because we're only differentiating the power. Now we multiply by the derivative of the inside. Now we know that the derivative of 10 is secant squared x. That's from the previous lesson. So we'll multiply by secant squared x. And now we're going to try to simplify as much as possible. Let's see what can be done here. So as you can see, we have a negative coefficient. We have secant squared, power is positive, so they will stay on top. So negative secant squared x. In the denominator, we'll have the 10x to the power of 2. So as you can see here in this case, we have the secant, which can be expressed in terms of cosine. So we have 1 over cosine squared x. And we have 10 squared x, that is sine squared over cosine squared. So as you can see, we have a division now of two fractions. The division can turn into multiplication, and that will flip the fraction that is in the denominator. So 1 over cosine squared x multiplied by cosine squared divided by sine squared x. Simplify the cosine squared. And we end up here with, we still have the negative. So negative 1 over sine squared x. And 1 over sine, the reciprocal of sine is cosecant, so this will end up being negative cosecant squared x. So the derivative of a cotan function would equal cosecant squared. And remember we said every term with a co will have a negative derivative. So for short, I like to memorize the derivative of cotan as, now remember everything with a co will have a negative derivative, and I know that for tan I have secant squared. So for cotan we have something similar, but obviously we'll have the cosecant, and the co-cos go together, so co minus again, cosecant squared x. If there is a function inside the angle, so an inside function, it means that at the end we have to multiply by the derivative of the inside. So these are the 3 proofs of derivatives of reciprocal trig functions. In the next video, we'll look into some examples. Thank you for watching. Bye for now.